Next talk is from Silvano Pecora. He is the Vice President of the United Nations Commission for Hydrology of the World Meteorological Organization. Thank you for coming and joining us.
Okay. Thank you very much, Mr. Chairman, for your introduction. And dear colleagues, friends, and participants, ladies and gentlemen, to me, it's really an honor to be here with all of you. And this is the place where I wanted to be. And on behalf of the WMO Commission for Hydrology, I would like to thank Franco Ricci and the University of Parma for this great opportunity to discuss about water. And I will provide my contribution from the perspective of an hydrologist, and in particular from the perspective of Commission for Hydrology. I hope that you are really familiar with it. Anyway, just a few notes about this organization, which is a specialized organization on weather, climate, and water, of course. And in particular, according to the WMO resolutions which are adopted by all the member states. We have 191 member states and territories participating to this organization. We support the free and unrestricted exchange of data, product, and service belonging to weather, climate, and water, because we are here to talk about water. So this is the organization. It is composed by the supreme body, which is the Congress, where all the member states are represented, and they used to meet every 4 years. And this Congress is supported by the Executive Council that meets every year, and where we have 43 members, experts, which are elected, and they should be elected this year in June again. And the activity of Congress is developed at regional level. So we have 6 regional associations, more or less 1 for each continent. And one is about this place, belongs to Europe, so it's Region 6. And then there are 7 technical commissions, and one is Commission for Hydrology. In December 2016, we started the new session Commission for Hydrology in Rome. There was an election. So you can see the new president, Mr. Harry Lins from the US, USGS, and you can also identify the new vice president. If not, it's me. And we arranged this, the new program for the next 4 years, according to these main blocks. One is belongs to measurement, monitoring, and info system. The other about services, products, forecast. And just because we have a number of requests coming from the member states, we take into account this type of request to the 2 other blocks, one about activities supported by the Secretariat, while the other is about activities supported by experts, in particular OPACIs, which are experts nominated by national permanent representatives. I want to start to discuss about water from this picture, which I took from the WMO Strategic Plan. So this is the analysis of the extreme events which occur in time, and as different type of extreme events, floods, droughts, extreme temperature, wildfires. And you can identify that the number of these disasters are increasing. So we are facing this type of situation for a number of reasons, including climate change. However, if we try to analyze these events according to the total number of victims, you can recognize that there's a decreasing number of total death. So that means that we know this type of events, we know the processes, we have observations, we have knowledge, we can provide a number of services to cope these extreme events. So in some way, we can identify the strategy which we adopted at WMO. We started from societal needs, and according to observations, data exchange, together with research and processing data processing, modeling, and forecast, we can provide a number of services, including weather services, climate services, and environmental and hydrological services as well, to obtain, again, a number of societal benefits, including disaster risk reduction, or resilience to climate variability, or again, sustainable use of natural resources, including water resources. In the previous picture, you identified the main block about observations. So this is what we call activities in basic systems. So how we collect data, how we check the quality of this data, how we manage this data, in particular, how we exchange this data to support the different applications for the purpose of managing or forecast or the defense of the soil territories, including during emergencies. There's an important program, the WMO Commission for Hydrology, which is the World Hydrological Cycle Observing System, WHYCOS. It's a program about capacity building. So we support the member states to improve their capacities about monitoring. And we started the first HYCOS, which is the components of this program, in the Mediterranean areas. Now we have most of the ongoing activities in Africa and in Central Asia. However, this capacity building, when I arrived at WMO in 2012, I identified an important gap. I greatly support training. I greatly support learning, for sure. But at the same time, we need to provide operational activities to the aim of planning, of management. We need to improve the data sharing to apply this information for the specific operational request. That's why we introduced the WHOS, which is the WMO Hydrological Observing System, which is the hydrological component of WHYCOS. WHYCOS is the integrated global observations all over the world about not only hydrology, but also climate, cryosphere, or the marine observations. And this WHYCOS is supported by WIS, so I think that the WHYCOS is what we are observing, while WIS is how we are sharing this data through the technology which today is available. So WIS is composed by a number of global nodes, more or less one for each continent, but however there are more than one GISC, and then some national nodes through which we share national informations, meteorological and hydrological observations as well. I will talk about WHOS. It's quite difficult to describe it, but I tried to simplify its description with this diagram. WHOS is composed by 7 components. One, data, because we share data. The other, format. We need to describe our data according to some format which could be a standardized or non-standardized format. Then we need a mechanism for sharing this data, which is the service, which could be an FTP, an email. However, today we use web services. But we need to take into account that there are different formats, different services, so it's very difficult. For sure, we can support data discovery, but not data access. That's why we introduced an additional component, which is the mediator, something which is used to translate from one format to the other, or from one service to the other. And just to simplify this type of a mechanism, we introduced an additional component, which is the broker, a layer between data users and data providers. Last but not least, the final component is the ontology, the description of what we are observing, the hydrosphere together with its chemical, biological, and physical part. So the application of these components at the local level, national level, regional level, global level allow the transfer, the dissemination of our products and observations all over the world for different type of application in a similar fashion for my house, my stream, my nation, my country, and of course the planet. It's not just a plan. This is an working system. I call it operational prototype because formally we will approve it in June this year during the next EC meeting. So this is the web portal where you can identify two main products, one a very simple product, and the other a very complex service. The simple product is a map, just a map with some dots representing each member states and offering information about the official web portals together with the links to historical and real-time data. So for instance, if you click in the dot representing Iceland, then you can reach their web portal and then you can obtain their data. However, again, this is a big constraint because probably you cannot use this type of information if we do not translate, we not manage this data in a suitable way. That's why we introduced this advanced architecture. So think of two national hydrological services offering their data according to whatever mechanism they prefer. And we can think that these services are registered into a catalog, WHOIS, and WHOIS is able to harvest and broker these national hydrological services in such a way that it can offer a catalog, a list of the available observations products in the world in the different parts of the planet. And the users, which could be a machine or web and desktop clients, can make the data discovery according to the variable, to the time, to the location, and they receive information from the catalog, and thanks to this meta information, they can retrieve data directly from the data providers or through the broker itself, mediating by a mediation of the requested data formats and services. When we request data, we use a number of operations offered by the server. So the server collects the requested information from the archives, and then the server transforms this information according to the requested format and service, and finally it delivers the information to the end users. This is how WHOIS works. The important aspect and functionality of WHOIS is the broker approach, because usually every type of catalog facilitates data discovery, but not data access. And that's why we introduced the broker to link data users and data providers and to facilitate data discovery and data access in such a way that we can support the governance and collaboration between all the stakeholders, all the hydrologists, and whoever is interested in water. This is the ontology. It's an incredible painting, especially in this room. But this is what we observe in water. So a number of concepts, hydrosphere, the chemical part, the biological part, till the variables, which we are observing, precipitation, water level, discharges. It's very important to identify the connection between all these concepts, because we need to improve the discovery of data. Otherwise, we have a plethora of data, and we don't know what type of data exists and how we can apply this information. And when I say concept, it means that we can introduce concepts such as drought and floods, so very common words which are useful for our applications. Just to simplify the functionality of WHOIS, think of data providers such as Canada. Canada is offering data according to FTP text files, a very common situation, but with a non-standardized mechanism. Thanks to WHOIS, we are able to apply this tool, very common in hydrology, for its Hydro desktop, which consumes a specific data format service types. And thanks to the broker, we are able to use this Hydro desktop, so we can search data in Canada, we can download data, and we can make any type of analysis in which we are interested. And the same is for web desktops, such as Sensor Web, which use a new standard, which is Sensor ML, a new service type named SOS2. And thanks to the broker, even if we have not this type of knowledge, we can apply these tools, and we are able to publish this data over internet. And in the case of Canada, we allow all the users to view the available observations and to download this data to check what happens in a specific river, in this case, the Canada. An additional functionality of WHOIS is the catalog. Even if I have not data, I can specify a catalog, a list, or a specific overview of the available data in the world. So think of that I select all the countries belonging to the Sava River Basin. The Sava is the main tributary of the Danube. And so with just a couple of clicks, I can create a specific catalog for the Sava, offering their information according to the standardized and non-standardized published interface. That means that WHOIS offers the possibility to improve the discovery of the available data. And at the end, through these simple endpoints, in a couple of clicks, we can handle their data and we can make any type of analysis. And it was a success. Thanks to this approach, we were able to support North America, Central America, all the countries belonging to the Arctic region, or China, or again, the Sava River Basin, or New Zealand, which is quite similar to Italy with a number of regions for a state. And so we federated their information. And South Africa or Niger, or again, the South America. And in WHOIS, you will find a list of these available catalogs. Let's try to move from data to information. It's very important to describe our observations. Otherwise, someone could apply this data without knowledge. And at WMO, we support a lot of standards. In particular, Commission for Hydrology created a working group together with OGC, the Open Geospatial Consortium. It's a very large consortium with about 500 members participating into this consortium. And I'm one of this chair. And in the case of hydrology, we developed many standards, in particular a suite named the WaterML 2 version 2, with a number of parts. Part 1 for the description of time series, the other for rating curves, discharges, cross-section, and then eye features, groundwater, and water quality as well. At WMO, we adopted some of these standards, and now they are, part 1 and part 2 are also WMO standards. And just to show you how we support and how we create standards, we start from a model, and then at the end we create XML instance, which become part of our technical regulations, and then these technical regulations are adopted by member states, so by national and meteorological and hydrological services in the world. And the last profile which we approved is WHYCOS metadata standard, which is the standard to describe observation for meteorology, climate, and water as well. It's very important, the description of observation. But let's try to move from information to knowledge. So we are supporting the evolution of data. This is what we are going to develop in the next years. The creation of a knowledge generation, in particular a knowledge-based platform. So we need to take into account not only observations, data, informations, but also models, algorithms, in a similar way that we adopted for the observations. So think of repositories of models, and the users can retrieve these models, apply these models in a specific part of the world, and linking these models to the available data offered by WHOIS itself. And this is the mechanism that we are implementing, and I hope to show you during the next version, the next Labirinto or delle acque. I hope so. But let's try to move from knowledge to wisdom, the final step, the most important step of the evolution of data. I want to describe this step with some examples. One comes from the South America, the application of WHOIS. So we federated all the observations for all the countries belonging to the Plata Basin. It's one of the largest catchment in the world. And so their data are offered through the mechanism which I already illustrated. But thanks to WHOS, we are able to apply tools such as the WETRA, which is a client for the management of risk of disasters. And this is a tool which is offered by the Italian government to the WMO for free, and we are applying it in many parts of the world. So we can use the WETRA to analyze what we are observing, in this case, about rainfall, or what could happen. We can identify the different type of meteorological forecast, but in particular, we can support hydrological forecast, and we can support probabilistic discharge forecast. We can take into account different type of scenarios together with the vulnerability of the territory, and at the end, we can deliver impact-based multi-hazard bulletin, so for alerting the people living in this part of the Plata Basin. Another example comes from Italy. The case of drought, and we suffer this type of extreme events, in particular this phenomenon of salt intrusion in the delta area, and the length of this intrusion is becoming longer and longer. That's why it is useful to have a very good observational network together with forecasting chains, but also together with the products from the marine community, the case of marine models applied to the Adriatic Sea, in such a way that we can forecast the salt intrusion in all the branches of the delta area in support of agriculture. Again, I showed how we can link different community, meteorology, hydrology, agriculture, and why not, economy. Another example from the case of urban areas, severe events which affected Genoa in 2014, thanks to the available data, which are very detailed information, we are able to make this type of simulation and to evaluate the impact in the city, and to evaluate the flood hazard and the economic losses. Of course, I'm taking into account losses in terms of infrastructure and structures, because if we take into account people, there's no comparison at all, of course. And thanks to this type of application, we can analyze different solutions. For instance, a new diversion channel, a new culvert for 2 streams near the city of Genoa, and we can evaluate the reduction of the damages in comparison with what we suffered during the year 2014. And then we can analyze, we can make an economical analysis, and we can identify the payback period. And that's the way which we should introduce in support of the management of the territory. There's a new program, Commission for Hydrology, which is the Hydrological Status Outlook System. So in some way we are promoting the applications of different models in different parts of the world. At the moment we started with 2 pilot cases, one for the Lake Victoria in Africa, the other in Southern Central Asia, and there's another pilot at global level. Anyway, it's a program in support for the evaluation of coping extreme events such as floods and droughts. And we have also another program named the Flash Flood Guidance System in support of this type of events, flash floods, with many applications in many parts of the world, which we are improving, taking into account a multimodal approach, taking into account also landslide and urban areas. And now we are also using seasonal and sub-seasonal forecast. So I hope that I tried to provide a complete overview of what we are developing at Commission for Hydrology, and we are also promoting many types of discussions about these issues and topics. So in Geneva we will meet together with many member states to discuss about, to promote collaboration, and why not to support, to identify funds in support of our ideas. So events which are very useful. Also this summit, this meeting is a very important contribution in support of our main target, which is linking people everywhere. And this place is symbolic, this labyrinth, with many ways which we can try to identify a suitable way in support of water, but at the same time, the labyrinth is many links, many ways for linking community, the marine, the meteorology, the economy, and so forth, in support of an important resources, environmental resources, which is water. So be water, my friends.